Prime numbers are often called the building blocks of mathematics. The first few prime numbers are 2, 3, 5, 7, 11, 13, 17. A prime number is a whole number which is greater than 1 and that can only be divided evenly by 1 and itself. If you try to divide it by any other number, it will leave a remainder. A natural question is, can there be a largest prime number? Maybe this list eventually ends. Maybe there is some gigantic prime number at the end of the universe and we just haven't found it yet. Today I want to show you a proof that answers this question once and for all. The proof was discovered by the Greek mathematician Euclid around 300 BC. That means the proof is 2300 years old. And despite its age, many mathematicians still consider it one of the most elegant proofs ever discovered. Let's see why. Before we begin, we need one important fact. Every whole number greater than 1 is either prime itself or can be broken down into prime factors. For example, 12 can be broken down into 2 times 2 times 3, 2 and 3 both are prime numbers. Similarly, 60 can be broken down into 2 times 2 times 3 times 5, 2, 3 and 5 are all prime numbers. 100 can be broken down into 2 times 2 times 5 times 5 and 2 and 5 are prime numbers. So, if a number isn't prime, we can keep breaking it apart until only primes remain. This idea is called the fundamental theorem of arithmetic. In simple terms, every whole number is built from prime numbers, and that is why primes are often called the building blocks of mathematics. We will need this fact in a moment. Now let's begin the proof. Suppose, for the sake of argument, that there are only finitely many prime numbers. Let's pretend these are all the prime numbers that exist: 2, 3, 5, 7 and 11. Of course, we know there are more, but let's imagine this list is complete. Now we multiply them together. We get 2310. We add 1 to this number and we get 2311. This new number is the heart of Euclid's proof. Now let's ask a simple question. Can 2311 be divided by 2? No, because 2310 is divisible by 2, but 2311 leaves a remainder of 1. Can it be divided by 3? Again, no. It leaves a remainder 1. What about 5? No. 7? No. 11? No. In fact, every prime number in our list leaves a remainder of 1. And that's because we multiplied them together and added exactly 1. Now comes the crucial step. What kind of number is 2311? There are only two possibilities. Either it is prime or it is composite. Let's look at both cases. Suppose 2311 is prime. Then we have found a prime number that wasn't in our original list. But our list was supposed to contain every prime number. So it contradicts our initial assumption that 2, 3, 5, 7 and 11 are the only prime numbers. Now suppose 2311 is composite. Then it must have prime factors. But none of those can be 2, 3, 5, 7 or 11. Because we already proved that none of them divide 2311. Therefore, there must be another prime factor not in our list. So it once again contradicts our initial assumption that 2, 3, 5, 7 and 11 are the only prime numbers. And here's the beautiful part. I never claimed that 2311 had to be prime. It might be prime, it might be composite. It doesn't matter. Either way, a new prime number appears. That is the genius of Euclid's argument. And notice something else. I never used anything special about the numbers 2, 3, 5, 7 and 11. You could give me a list of 100 prime numbers or 1,000 or 1,000,000. I could multiply them all together, add 1 and repeat exactly the same reasoning. No matter how long the list is, it can never contain all prime numbers. There is always another one beyond it. And so we arrive at our conclusion. There cannot be a largest prime number. The list of prime numbers never ends. There are infinitely many primes. What I love about this proof is how little mathematics it uses. Just multiplication, just addition, and yet it proves a statement about infinity. More than 2300 years after Euclid discovered it, mathematicians still admire the proof for its simplicity and elegance. Sometimes the deepest truths in mathematics come from the simplest ideas. Thank you for watching, and if you enjoyed this video, please consider liking and subscribing. I am building this channel around mathematics, physics, scientific ideas and explaining from first principles. And if there's a topic you've always wanted to understand, let me know in the comments. It might become a future video.